Question number 17. The volume of two similar solid cylinders are 4,096 centimeters cubed and 1,728 centimeters cubed. If the curved surface area of the smaller one is 112 centimeters square, find the height of the larger cylinder if the radius is 7 centimeters. So what you need to remember here is how to relate volume scale factor with linear scale factor and area scale factor with linear scale factor. So the first thing that we can find from our question is the volume scale factor, because we are given the volumes of two cylinders, the smaller and the bigger. So you remember that we said that to get volume scale factor from linear scale factor, we said that the volume scale factor, we said volume scale factor equals to linear scale factor cubed, equals to linear scale factor, this one is cubed. We also said that to get area scale factor from linear scale factor, we said that area scale factor equals to linear scale factor squared. So that is how we get the area scale factor. So the first thing we want to do here, is to find the volume scale factor. Volume scale factor equals to the volume of the image, and mostly we take the bigger one to be the image. So the volume of the image, which is 4096 all over 1728. Now what you do here, ensure you write this one in your calculator while it is in fraction form, so that you retain everything in fraction to make your work easier. So what you do, you press 4096 in your calculator, then you press the AB over C. In your calculator you can see AB over C somewhere there. AB over C, you find a fraction, then you press 1728. So you press equal sign, you'll find it giving you 210 over 27. What you do, press shift, press still A over B, you'll find it in improper fraction as 64 over 27. So you find 64 all over 27. So if you find that, now from there you can, if you have the volume scale factor, you can find the linear scale factor, because we said the volume scale factor equals to linear scale factor cubed, meaning that linear scale factor is the cube root of volume scale factor. So our linear scale factor, from here we can say that the linear scale factor was the cube root. It was, you find the cube root of 64 over 27. 64 all over 27. Cube root of 64 over 27. You press your calculator, the cube root of 64 all over 27, you'll find it to be 16 over 9. Cube root, 4 over 3. You'll find it to be 4 over 3 as the cube root of, that is, cube root of 64 is 4, and the cube root of 27 is 3. So that becomes the linear scale factor. Another to have the linear scale factor, remember we have been given the curved surface area of the smaller cone. So that means we find the area scale factor, so that we consider areas. So area scale factor will be equal to linear scale factor squared, will be equal to 4 all over 3. We square this, 4 over 3 squared. So if we square 4 over 3, 4 squared, you get 16. You get it as 16 all over 9. So that is the area scale factor. Now we know, we understand that we can easily find now the area of the area of the larger is what we are asking. So I can easily relate now 16 with the areas, 16 all over 9, 16 all over 9 equals to, if I call the area of the larger to be x, equals to x all over the area of the smaller you are given as 112, over 112. So if you divide by 112, you cross multiply, that means your x will be equal to 112 times 16, 112 times, if I multiply by 16, then I will also divide by 9. So that means my x, that is the area of the area, 16 times 12 gives you 1792 divided by 9, so that gives you 199. It gives 199.11 centimeter square. So that becomes the area of the larger cylinder. So if this is the area of the larger cylinder, 111, we know that to find curved surface area, to get our curved surface area equals to, for a cylinder it is 2 pi r h. That's to get the volume or curved surface area of a cylinder. So that means this is the curved surface area of the cylinder now, of the larger cylinder. So it implies that 199.11 will be equal to 2. You take pi to be 22/7, 2 times 22/7 times my radius, you were told there is 7 centimeter, times 7, then times h. Remember 7 and 7 will cancel out. 7 will cancel with this 7, so we remain with 22 times 2, which is 44. So h is equals to 199.11 divided by 44. 199.11 divided by 2 times 22 is 44, divided by 44, meaning that now you get your h. So h equals 2. If you divide, you get 4.525. 4.525 centimeters. 4.525 centimeters. So that is, this becomes your h. Your h as 4.525 centimeters. So that is your h, and that is what you are required to do. That's what you are required to do. That is what you are required to do. So that was your requirement. You were supposed to find, that is how you score your 4 marks. You are supposed to find you read the volume scale factor with linear scale factor and the area scale factor with linear scale factor, so that you are able now to find the height of the new the height of the larger cylinder. Now part B of question 17, we are talking about a cone and a hemisphere. A cone and a hemisphere. So you must remember the volume of a cone and the volume of a sphere. Volume of a sphere is 4/3 pi r cubed, and the volume of a cone is a third. Volume of a cone is a third pi r. So sorry, you need to relate. Now let's deal with it the way it is. You're asking that the diagram below represents a solid made up of a hemisphere mounted on a cone. The radius of the hemisphere and the cone are each 6 cm, and the height of the cone is 9 cm. Find the volume of the solid. We need to find the volume of the solid. So to get the volume of the solid, it is volume of the hemisphere plus the volume of the cone. Volume of the hemisphere plus the volume of a cone. And we know a sphere is 4/3 pi r cubed. Volume of a sphere is 4/3 pi r cubed. So that means hemisphere is a half of a sphere. So volume of a hemisphere, volume for hemisphere will be equal to volume of the hemisphere. So when we talk about the hemisphere, now volume of the hemisphere, we have said it's a half because it's a half of a sphere. A half times 4/3 pi r cubed, which is the same as a half times 4/3 then times 22/7 times r. Remember the radius we are given as 6 cubed times 6 cubed times 6 times 6 cubed times 6 cubed. So if you multiply all of these, you'll get, because I have this comes here 2, so we shall have 44 times 6 cubed all over 21. 44 times 6 cubed all over 21. You will find it as you multiply by using your calculator. You will find this one to be 452 452.5714 5714 centimeters square. Remember, it's in centimeters, so it is centimeters square. So that is the volume, centimeters cubed, because we are talking about the volume. Centimeters cubed. We are talking about volume, should be centimeters cubed, should be in cubed. Centimeters cubed. Centimeters cubed should be in centimeters cubed. So we talk about 452 point. Now we talk about the cone. For that cone, for a cone, For a cone, we know that the volume equals to a third by r squared h. A third by r squared h. This is a third by r squared, a third by r squared h, which is equal to, now a third, that's form of a cone, times pi is 22/7 times our r is 6 squared times our h is 9. Now you multiply that by using your calculator, you will find that volume to be 339. You find it to be 339.4286 centimeters cubed. So after you get that volume, you've got the volume of the cone and the volume of the hemisphere. You add the two to get the volume of the solid. Volume total, that is the total volume. Total volume will be equal to, we add the two, that is 452.571.5.55714. We add 339 point, we add 339.4286. So if you add, this gives 10, 0 carry 1, this gives 10, 0 carry 1, this gives 9, 10, 0 carry 1, 9, 10, 0 carry 1. So this is 9, 10, 10, 12. So we shall have 2. We carry 1, so it gives you 9. This gives you 7. So it will become 792 centimeters cubed. 792 centimeters cubed. So that is the area, that's the volume of the solid. The volume of the solid. That is the volume of the solid. So that is how we find the volume of the solid. We find the volume of the hemisphere plus the volume of the cone to get the volume of the solid. So that's what we're supposed to do. Now we move on and do question number 18. We move on and do question number 18. Question number 18. We move on and do our question number 18. Question number 18. Now, question number 18 is talking about, question number 18, we are talking about bearing. These are from one topic. 3 towns, X, Y, and Z, are such that X is on a bearing of 120 degrees and 20 kilometers from Y. Town Z is on a bearing of 220 degrees and 12 kilometers from X. So your starting point, first of all, you must make a sketch. A sketch is very important before you draw. Yes, I have drawn here, but the first thing you do, you want to make a sketch such that if I make a sketch like in here, I know I'm starting from y, so that you are able to know that your paper, how will you draw in your paper. So if I make a sketch here, for instance, I start with y, and I'm told that say that x is on a bearing of 120 degrees and 20 kilometers from y. So if I start with y, remember 120, that is a compass bearing that you read from the north. We read compass bearing, we read from the north in what we call clockwise direction. So it must start from here, the north, clockwise direction. This is our north. We start from the north, clockwise direction. 120, remember this is 90. This up to here is 180. So that means 120 can be, we can have like a small here. We say that is 120, and then we call this our point x, and this was your point y. So this is your point x. Then remember this, all this is 120, meaning this is 90. 120 minus 90, 120 minus 90, it gives you, if you talk about 120 minus 90, so that you are able to know the angles you draw. So this is 90, this is 30, I mean, because it gives you 30. So if this is 30, meaning the angle here is 60, the angle here is 60, here is 60. So this 60, the whole of it is 120. So from there, you are also told that town Z is on a pairing of 220 and 12 kilometers from X. Remember, all this was 20 kilometers. And then you also told that 220 degrees and 12 kilometers from X. 220 from X. We are measuring 220 from X. So 220 will be where? This 180, 220 will come this side, and 12 kilometers. So 220 will lie around, because up to here is 270, so 220 can be somewhere here. Then this is 220. If it is 220, 180 minus 220 minus 180, you get is 40 degrees. So this 40 and this is 50. So 50, remember this is 30 here, because these are alternate. This is the 30 here, and therefore this is 30, and this 50, this 50. So meaning the whole of this angle is 80 degrees. The whole of this angle is 80 degrees. 80 degrees. And therefore, I'm told that you get a point, you move to a point Z. A point Z. If you have a straight line there, so this is a point Z. So you make a nothing, and all that you meet your point Z there. So if I make my point Z here, then I'm told that using a scale of this. So from there, that means you will easily join. You will easily join as per, okay, you know your figure. This is a sketch. Remember, it's not necessary that it will be here. It might be even here. So what you do, that is a sketch. You just leave it at that level, or just join if you wanted, but you know you are going to draw to see. So what you do, now you draw the actual. You draw the actual, and the actual is what I did here. The actual is what I did here. So what you'll do, because you started with y here, you are to measure 120 degrees. 120 degrees, if you made a nothing, and then this a nothing, so you want to measure from this point. If you put your protractor here and measure the clockwise up to 120, you can read 120, draw a straight line. And then you have used a scale, because you are told to using a scale of 1 centimeter to represent 2 kilometers. So you are given the scale to use. So that means this 20 kilometer becomes 10 centimeter. So you also, after you've drawn a straight line, measure 10 centimeter. Where the 10 centimeter arrives, you get your 10 centimeter, you draw a nothing there. After drawing a nothing there, you just have it joined there. Then from there, you are told from here, you remember you are measuring. What you do, we said here is 40. So you just measure 40 from this point. From this point, you read that way. That means you should have read the anti-clockwise way to get your 40 degrees. Then after getting 40 degrees, you join, and then you measure 6 centimeters, because this 12 kilometers divided by 2, you get 6 centimeters. You measure 6 centimeters here. Then wherever the 6 centimeters you get, you draw nothing. Then after joining, you will realize that you can only join to the other point straight. From here, you can join the other point straight to get to your other point here. You join straight. So from there, you are done with the positions. You score your 3 marks. Then from there, another question, part B. You find the distance between Y and Z. The distance between Y and Z. Between Y and Z. After joining, just measure it from here to here. You will get it in centimeter as 9.9. If you get 9.9, it's plus or minus 0.1. Somebody can get 9.8, or somebody can get 10. So if you get 10, that means you get 10, then times 2 is 20. So if you got 20, or if you got 18, because 9.8 times 2 is 9.8 times 2 is 19.6. So you can get 19.6, between 19.6 to 20. That one will be okay, because 19.6, 19.7, 19.8 up to 20, you will be okay. Kilometers. Remember, you must change it to kilometers after measuring and I must see that you have measured in centimeters, then you multiply by the scale that you used. It must be seen for you to score the marks. So from there you are told that you measure the pairing of x from z. The bearing of x, if we had an x here, from z is here. So you come to z, you measure this angle. The bearing of x from z, if I measure this angle, is 40 degrees. So it is plus or minus 1. So somebody can give 41, or somebody can give 39. That is correct. Number 3, the bearing of z from y. So you go to y and get z from y. You measure now from y. You measure. Remember, this is already 90. This is already 90. Then you measure, or just put your protractor and measure the whole angle here. You get it as 158 degrees. 158 degrees. So if you get it 158 degrees, it is plus or minus 1. So somebody can say 159 or 157. Now from there, the last part 4, you find the area of the figure bounded by XYZ, bounded by XYZ, this area. Now what we do for us to get this area, remember we know that we know this 6, we know this 10, we know this as we measured this one to be 19 point, you change them into, okay, calculate what in, you can decide to use it in kilometers, or you first of all calculate in centimeters, then you convert. Still it's okay. If I use it in centimeters, remember this 10, this 6, and this is 9.9 or 9.8, whichever that you found, but accuracy is most important. So you can use Hero's formula to find this. Or, now that I have this angle, there is no need. I use sine rule. Sine rule, half AB sine theta. If I use half times 6 times 10 times the sine of 80, because the whole of this angle I found it to be 80, I'll be able to find the area as 29.544 centimeters square. 544 centimeters square. So if I find the area in centimeters square, remember it's good to deal with, because we have used centimeters and the degrees, so it's good. There is no need that you change so that you calculate. No, just find that area. While if you are using half AB sin theta, while in centimeters, if I find this in centimeters, then that is the area. But remember, you are supposed to find the area in kilometers square, because whatever you were given was in kilometers. So the actual should be in kilometers square. Now remember, we have used 1 centimeter to represent 2 kilometers. So that means 1 centimeter square will represent 2 times 2. So 1 centimeter square will represent 2 times 2, which is 4 kilometers square. Meaning that 29, this is square, 29.4544 centimeters square will be what? It will be 29.544 times 4 kilometers square. It will be times 4 kilometers square. So if you multiply times 4, 29.54 times 29.544, if I square, or if I multiply times 4, it gives me 118.1. It is 118.176 kilometers square, and that is the answer that will be marked and not the centimeter square, kilometer square. This is the answer that will be marked and not this one. This one is you get a mark, but the correct answer will be marked on this. You'll be marked on this. So that is how you are supposed to do questions on pairing. Pairing is a very simple question if you follow the instructions. So the first thing, you make a sketch, then after sketch, then you draw the actual using a scale if you are given. If you are not given, use an appropriate scale. So that is how we do it. Let us do question number 19. Question number 19. So this is just, it was carrying 2 marks, 1 mark, 1 mark, 3 marks, and calculate the area. Number 19, question number 19, we are dealing with the figure ABDE below represents cohesive grazing land. It is divided into 3 paddocks, ABE, BCE, and CDE. So angle ABE is 8, angle ABE is 8. So I'm told that this angle here is 8, angle ABE is 8. This is 8. Angle CBE is 60, angle CBE is 60, CBE, this angle, I'm told is 60. And angle CDE is 62. This one is 62. Remember, this is 90. So, and AB is 260. A to B is 260. C to D is 8. So I'm told to calculate to the nearest meter. Remember, it is the nearest meter. Answer the question as asked. To the nearest meter, we calculate. CE. I calculate CE to the nearest meter. Remember the form to trigonometry. Now we deal with the cosine SOHCAHTOA. When we talk about SOHCAHTOA, you must remember SOHCAHTOA. So you have to remember the SOHCAHTOA. It will assist you. So when we talk about SOHCAHTOA, means sine of theta. Theta in this case is 62, and I'm dealing with the this is adjacent to this, and this is opposite. This is opposite to this. So I'm after opposite. So I'm dealing with the opposite and the adjacent, and that one is the tangent. Tan of theta is opposite of adjacent. Cos of this is adjacent of hypotenuse. This is a hypotenuse. And the sine of theta is equal to opposite over hypotenuse. So I'm dealing with the CE. So that means I deal with the tangent. So I'll say that tan of theta, to get CE, I'll say that tan theta, now in this case the theta is 62, tan of 62 equals to, the opposite to 62 is CE, and that's what I'm looking for. CE equals to CE all over TOA all over adjacent. Adjacent to 62 is 80 meters. All over 80 meters. So that means to get my CE, I multiply CE equals to 80 tan 62. 80 equals to 80 tan of 62. Tangent of 62. If you multiply 80 times tangent of 62, 80 times tangent of 62, you get 150 point. You get 150. Just you calculate using your calculator. 150.458 meter. But remember, we are dealing with nearest meter. If we talk about 458, but we are dealing with the nearest meter. So the nearest meter, you cannot round it, is 150. So you just write equals to 150 meters. Remember, in the exam, in this exam, this will be marked, but this is not the answer because you were told nearest meter. So nearest meter, you must write the 150 as the nearest meter and not 150 point whatever. So nearest meter is 150. 150 meters is the nearest. That is 2 marks. That is, and this one also carries a mark. So you have the 2 marks. Then from there, the other question is that let us look at the other question. The other question, calculate the length of AE. So we need to find the length of AE and then the perimeter. So first of all, we deal with the length of AE. Length of AE. How can we find the length of AE? How can we find the length of AE? How can we find the length of AE? Length of AE. So to get the length of AE, we need from A to E. So first of all, we know this angle, like we said, this angle, this angle is 80. This angle is 80 and this angle is 60. So now that we have this side, we need this side so that we use cosine rule, that's the form 3, to get AE. So what we do, we first of all find BE. To get my BE, B to E, because this is also 90 and we have this angle. So if we have this angle, remember CB we don't have. We don't have CB, but we have this one to the nearest meter as 150. We have found it to be 150. So if we found this to the nearest meter to be 150, so that means if I use the same 150 nearest meter, then I'll be able to find the hypotenuse. Because remember this is the opposite to this, so I use sine. So sine of what? I say that is sine of 60, so that I get the hypotenuse BE. Sine of 60 equals to, opposite to 60 is 150, all over hypotenuse, which is BE. So to get BE equals to 150 all over sine of 60. 150 divided by sine of 60, divided by sine 60. If you divide 150 divided by sine of 60, 150 divided by sine of 60, 150 divided by sine of 60, when you use your calculator, you'll find it to be 173.20. 173.20 to the nearest meter is 173. 0.20 or 0.21 meters, now, which gives you to the nearest as 173 meters. It is good to first of all write what you find. You can write as many decimal places, at least 4 decimal places. After writing to 4 decimal places, then you write the correct answer as per the instruction given. So you get this one to be 173 meters. After getting 173 meters, remember I'm after AE. This is 173. 173. But that's not my AE. I'm after AE. AE I use now because I have this one and I have this one. There is no perpendicular here, so that now I use SOHCAHTOA. In this case now I use the cosine rule. Or if I had another angle here, there is the sine rule. So you can use the sine rule. 1 over sine theta, A over sine A equals to B over sine B. If I had another angle like this one, but I cannot find this angle that easily. So instead of struggling like that, and I have this side and I have this one, I use the cosine rule. And the cosine rule states that in this case AE squared, we say that AE squared equals to 173 squared plus 260 squared plus 260 squared, then minus 2 times 260 then times 173 times the cos of 80 times cos 80 degrees. So if I multiply that, 173 squared plus 260 squared, 173 squared plus 260 squared, if you add the two, you get 97,529. This gives you 97,529. Then I will subtract 2 times 260, 2 times 260 times 173, then whatever I get times cos of 80, I will get 15,621 minus 15,000 621.3, 621 to 1.39.39. So if I subtract, whatever I get now, AE is the square root. AE will be the square root. AE will be equal to the square root of what I get here. And what I get, this is 97,529 divided by, minus 621.39. I get 81,907, 81,907.61, and that will give me, this will be equal to the square root of that. Square root of the answer gives you 286.19. That means nearest meter is 286. 286 meters. 286 meters. So 286 meters, AE is 286 286 meters, 286 meters, 286 meters, 286 meters. 286 meters is my AE. So if I have that, then I'm asking the last question to find the perimeter. So I have this one, I have this, I have also this one here. I have 286. I have DE. I can find using SOHCAHTOA. I can also find using SOHCAHTOA BE, so that I find the perimeter. So the perimeter would be, I find DE. If I find DE, 80 squared plus 150 squared is square root. 80 squared plus, that is using Pythagoras, it is 80 squared plus 150 squared. I'll get the square root of the answer. Square root of the answer, it gives me 170. So this is 170. 170 meters, 80 meters, and this one, I can also use 173 squared minus 150 squared square root. 173 squared minus 150 squared. Whatever I get, I find the square root of the answer. I get as 86 point, to the nearest is 86 meters. 86 meters. So the perimeter, I will have to add all of them. Then I'll find, if I add, I'll find 170. Let me start with 286 plus 170 plus 80 plus 86 plus 260. I'll find it to be 882 meters. 882 meters. So that is the perimeter. Perimeter is 882 meters. So if I find the perimeter to be 882 meters, 882 meters, then now I need to find now I need to go and do part B of the question. Part B of the question. I need to find part B of the question. So that is how you were supposed to handle this question. That is how you were supposed to handle this question. Then we go to part B of the question. Part B of the question. We go and do part B of the question. Part B of the question. Good. Now we go and do part B of the question. We have even done the perimeter. Now the part B of the question is asking that Kcse fenced each side of the three triangular buttocks with 3 strands of wire. He left a 2.4 meter wide gate at side AB, BE, and CE. If the wire that he used was bought in rolls of 500 meter, determine the number of rolls of wire that he bought. So first of all, we found the perimeter, the whole round to be 882. We found it to be 882 meters. But there is, for us to know the wire we use, there are 3 sides that we do not add. So the required wire. So first of all, you need the required wire. The required wire will be equal to, now 882 that we found, 882 that we found, plus the 150 that we had found, that is CE. CE we had found it to be 150, that is, we have not added it, plus 150, plus we did not also add side BE. Side BE, that is 173 that we found. Which other side we didn't add? Those are the only 2 that we do not add. Then whatever we get, we subtract the gate. The gate 2 meter times 3. Remember, you leave 3 sides. 2.4 times 3 times 3. So 2.4 times 3, because it is 3 places, you get 7.2. So we subtract 7.2 meters, 0.2 meters to get the required, whatever you will require. So what you require here is 882 plus 150 plus 173. Then what you get, less 7.2, less 7.2, then you get 1,198, 197.8 and 97.8 meters. This is what was required, and this was sold. It was sold in rolls of 50. So the number of rolls that were required will be the required length, that is 11 to the nearest meter is 1198. 1198 to the nearest meter, 1198 to the nearest meter, divided by 500, divided by 500, 1198 divided by 500. This gives you 1198 divided by 500, divided by 500. That gives you 2.396. 2.396. 2.396. That means you needed 2 rolls, and it's not half, but there is an extra roll, of a roll. So you cannot buy 2 only. You buy more than 2, which is 3 rolls. So number of rolls, it is 3 and not. So number becomes of rolls becomes 3. 3 rolls. 3 rolls. That is what you required. 3 rolls. So I must see 3 rolls as the answer. 3 rolls is the answer. Is the correct answer and not 2 point. Because rolls cannot be in point form. Rolls cannot be in point form. So you needed 3 rolls. So this is the answer. That is the answer. Now, so that is how you are supposed to do such a question. Given that such a question, that is what you should do, and follow the instructions. Follow the instructions. That's what you do. Follow the instructions. Follow the instructions given. Then we go to question number. Need to do question number 20. Question number 20. Now, question number 20 is talking about the data below that is recorded on a daily record of sugar sold in one of the supermarkets in Kisumu town, which sells any in proportion in kilograms. Any proportion in kilograms. So all this is sugar kg, mass of sugar in kg. That is, mass of sugar should be in kg. Should be in kg. So the mass of sugar in kg. Now, number of people. You remember number of people, we can call it this frequency. So that is the frequency. So from here, determine the total number of people who bought sugar from this supermarket on that day. So we can call cumulative frequency. So if we deal with cumulative frequency, we are able to give the number. So cumulative frequency, we start with 22. Remember, it is going to assist us because of calculating the median. Calculating the median. Calculate the mean. Yeah, calculate the mean, not the median. We are talking about the mean. Okay, it's okay. Then we use 22. 22 plus that 8. 22 plus 38 gives you 60. So next is 60. In this class now, cumulatively, we shall have 60 people who have feasted. Now in this class, cumulatively, we plus 14. We plus 14. Cumulatively, we shall have 74 people feasted at the supermarket at this point. And then cumulatively, we plus 12. Plus 12. Then at this point, we shall have had 86 people feasted there. Feasted the supermarket. Then cumulatively up to this, it's 96. When you add 10, gives you 96 people feasted that. And then you add 10, gives you 100. So the number, the total number of people feasted were 100. And then calculate the mean. So I can find an x. X is the midpoint. When we talk about x, is the midpoint. X, if I find x, then I also find fx. Fx. So x, if I draw this, I complete my table so that I have the x and fx. It's good to write your table in vertical form to make your work easier, to be able to see clearly. X is the midpoint. 0.9 plus 0.5 plus 0.9. You divide by 2 for you to find the midpoint. 0.5 plus 0.9. You divide by 2, you'll get 0.7. You get 0.7. You divide by 2, you get 0.7. 0.7. You divide by 2, you get 1.2. You add this, you divide by 2, you get 2.2. No, 1.5 plus 1.7. You add, you get 2.2. You add, you get 2.7. And finally you add, you get 3.2. We need to find fx. That is, we multiply this and this, we get 15.4. This will assist us to get the mean. Multiply this, you get 45.6. You multiply this 14 times 1.7, you get 23.8. 23.8. So 2.2 times 12. 2.2 times 12, you get 26.4. You get 26.4. 2.2 times 12. 2.2 times 12. 26.4. You get 26.4. 2.7 times 10. This gives you 27. And finally, 4 times 3.2, you get 12.8. We need to find the sum, that is summation of fx. Summation of fx. We add all these, summation of fx gives you 151. If you add it, you will find 151. And remember, 100 is the same as summation of f, the frequency, equals to that. And we know, calculate the mean. Remember, mean, we know that mean, summation, mean is equals to mean, x bar mean is the mean, equals to summation of fx, summation of fx, all over summation of f, and that is equal to, this is equal to 151 all over 100, which gives you 1.51 kgs. That is the mean mass. 1.51 kg. That is the mean mass. Now, if you are done with that, but remember, cumulative frequency I'll use, because part D, I'll be asked to calculate the median. Part D, I'm asked to calculate the median. Okay, it's okay, I'll do it after drawing. Now I'll be asked but see that I draw the histogram. But see, I'll be asked to draw the histogram. Now what I do, just move. Okay, these cumulative frequencies will assist me, but later on calculating the histogram. On calculating the median, not the histogram. Now, on the grid provided, draw histogram of the representatives of the mass of sugar sold on that particular day. Remember, from above, we had frequencies between 4 and the maximum was 38, the highest frequency. And a class with the highest frequency we call it the model class, and the highest frequency we call it the model frequency. So the model frequency is 38, and The model class is 10214. Now I'm asked to draw a histogram. A histogram, if the class width is constant, and you remember you look at our table. If you look at our table, so that we look at the class widths. If we look at the class width, remember we use the upper limit. Histogram is the frequency or cumulative frequency. I mean frequency or frequency density in the y-axis versus upper limit in the x-axis. Now, when we talk about this class, in this class or this class, we need to calculate the class width. First of all, you need to know the limits. Remember here we have 0.5 to 0.9. Then the next class starts with 1.0 to 1.4. Next 1.5. So that means there are limits. And if there are limits, you look at the least unit of measurement here is 0.1. 0.1. If it was 0.05, then it is 0.01. So if the least unit is 0.1, we divide by 2 to get 0.1, we divide by 2 to get 0.05. So 0.05 is the error, is the absolute error. Therefore, that's what we minus in the lower limit and we add in the upper limit. So the limits now, the limits were supposed to be, if I talk about the limits, I start with the limits. The limits here, it is 0. The lower limit here is 0.5 minus 0.05, it is 0.45. 2, if you add this one, it becomes 0.95. 0.95, that is the upper limit. The next it is you divide minus 0.05 becomes 0.95. 0.95. And the next becomes 1.45. And the trend continues. So if I subtract this and this, I get 0.5. So my I meaning what? I is the class width. Class width is constant, is 0.5. If you also come here, you find the class width is 0.5. Because I subtract 1.45 minus 0.95 gives you that. You also change this one to be 1.95 minus 1.45 also gives you 0.5. So these classes were constant. If the class width were constant, then we use what we call, if you continue with the same trend, you change this one to the upper limit to be 1.95 and this with lower limit becomes 1.45, you subtract, you get 0.5. This becomes 1.95 and this becomes 2.45, you subtract, you get 0.5. So the class width was constant of 0.5. If the class width is constant, then we use frequency and not cumulative, and not what we call frequency density in the y-axis of our histogram, and we use the upper limits in the x-axis. So what you do here, if we move and draw our histogram, here, let us draw our histogram. Now, I will have to think of a good scale because I need the upper limits and against the frequencies. And the frequencies were 22 and maximum from 4 to a maximum of 40. So if I think, remember the frequencies are on the y-axis. If I think of a scale, let me use a good color. If I think of a scale here, I think like on the y-axis I use, if this is my 0, if I think of 10, so that means 1, 2, 3, 4, 5. Each has 2. 10, 20, 30, 40, it will be okay. 10, 20, that is, remember, this is the frequency, that's the number. You can call it frequency or number of people. 20, 30, and this is my 40. That is my 40 as the y-axis. And the x-axis, now I use upper limits. The upper limits, remember, we started with 0.45. So the lower limit of the first class is 0.45. So I start with 0.45 here, 0.45 here. Remember, they are constant. So each 1, 2, 3, 4, 5. Each 5, remember, the whole thing is 0.5, the difference. So each one, if it continues with 0.1, it is okay. So that I have now the next here as 0.95 to be here, 0.95 high here. Then here we also have 1.45. You continue with the difference, 1.95. Or that 2 point, or that we continue. So we shall have 0.95 here, 0.95. The next, let me write, the next is 0.95. We shall have next as 0.95, 1.45. We shall have 1.45. Then next is 1.95. The next is 2.45, because that difference is constant. Next is 2.95. Then next is 3.45. And that's the last one. Now you need to draw the histograms. The histogram, remember the first one, the first class had a frequency of 22. So as a frequency of 22, so 22 would be, remember this one I gave each carrying 2. So 22 would be here. From here, you draw, because that is where it is, and then you give that, you draw those pairs now. So this is the first pair. Remember, a histogram, in my other forums I've said that there is a difference between a histogram and a bar chart, because a histogram, all the bars are touch each other, but a bar graph, they are separated. So the next one is now from here to here. That is frequency of 38. Frequency of 38. 38 will be here. So I'll have to join here 38 there. I'll have to draw it. I'll have to draw it. I'll have to draw it. Then I draw it this way. The next has a frequency of 14. The next has a frequency of 14. They are uniform, remember. 14 will be, this is 12 because they have 2. 14 will be here. Will be here. So that is our 14. Our 14 here. The next is a frequency of 12. Frequency of 12 will be here. Frequency of 12, you draw that histogram, those bars. Now you're done. The next is a frequency of 10. Frequency of 10 will be exactly here. Draw using a straight line, just have a straight line there. The next is a frequency of 4. Next is a frequency 1, 2. 1, 2 will represent 4. Next is a frequency of 4. The first two divisions. And remember, it's good to write that the divisions that you have used, that is small squares represent how many, that is. Like as can say here, the y-axis, one division will represent, one division will be equal to 10 over 10 all over 5, because they are 5. The value is 10 all over 5. So one division will represent 2 what? 2 people. Because we are dealing with people. Then on the x-axis, one division will represent 0.5 divided by 5, 0.5 divided by 5, which is equal to 0.1 kg. Each represents 0.1 kg. So you get your scale. Then you are done with your histogram. You are asked to draw part D. You are asked to draw a line to show the median. So first of all, you need to calculate the median. First, we need to calculate the median. For us to get the median, remember we said that median equals to L1, meaning it is lower limit of the median class, plus brackets n is the cumulative frequency over 2, because median is half over 2. Then this is minus frequency, cumulative frequency above the median class, all over frequency of the median class. This is frequency of the median class, then times I is the class width. So our lower limit, the median class, it is half of 100 is 50. Where does the cumulative frequency of 50 lie? Remember, if you go back to our table, you realize where it lies. If we go back to our table, cumulative frequency of 50, you will see where it lies. 50 will lie where? Cumulative frequency, remember this is 22. So plus 38 gives you 60. So 50 does not lie on the 22, but lies on this, on the 38. So it lies on the second class, which is 1 to 1.4, 1.0 to 1.4. So that is the class I'm dealing with, 1.0 to 1.4. So I'm dealing with a class of 1.0. Lower limit is now 1.0 minus 0.05. It is the lower limit of that, which is equal to, lower limit of that is 1.0 minus 0.05. We get 0.95. 0.95, then plus n is the cumulative frequency, which is 100 divided by 2 is 50. So we shall have 50 over 2. Okay, which becomes 50 minus cumulative frequency above the median class. So cumulative frequency above the median class, remember the median class is 60, so above is 22. The first one had 22. That was the first one. Then all over frequency of the median class is the second one, which is 38, like we have seen from above, times I, which is 0.5. I is the class width. So you'll find 50 minus 22, you get your 50 minus 22, 50 minus 22, you get is 28. 50 minus 22 is 28. So 28 divided by that 8, you get is 0.73, then times 0.5 times 0.5, you will get it 0.3684. 0.3684. So we add the two, our median now. Our median equals to 0.95, 0.95 plus 0.3684, 0.3684. When you add the two, 0.3684, 0.3684, when you add 0.95, it gives you 1.31, it gives you 1.3. Remember, we are calculating the median, estimate the median mass, so it is 1.32, 1.32 kgs, the median mass. That is the median, 1.32 kgs. So if we get 1.32 kgs as the median, remember we need to locate where the median is so that we draw a line. So 1.32, if this is 1.43, it must be around here. So what we do, we said 5 is 1 is 0.1. 1 represents 0.1 kg. That is one division, is 0.1 kg. So what about 1.32? 1.32 we divide by 1.32 divided by 0.1, so that we get how many. There will be 13 of them. Remember, this is 1, 2, 3, 4, 5. This is up to here is supposed to be 1.45, and I'm talking about 1.3. One of it has 0.1, 0.1, 0.2, 0.3, 0.4, 0.5. It is true. This is 5, 10 up to here. It is 1.32. One has this is up to here, 1, 2, 3, 4, 5. So the difference here is 10. The value is 10 of them, and the value that is 0.5 divided by 0.5 divided by 5. It was giving me 0.1. So 1.32 kg will be equal to what? How many of them? If times 1, yes. So it is 1.32. 1.3 divided by 0.1. 30. So you get them as what? 10, 11, 12, 13. 1.32. This is 0.545. So it's supposed to be around here. 1.32 should be around here, because this is 0.4, 0.995, 0.95 plus 0.1. So the next year 0.95, 0.95 plus 0.1. So it gives me 1.05 plus 0.1 to give me 1.15 plus 0.1 give me 1.25, the third one, plus 0.1 give me 1.35. The fourth one is where we have 1.35 around there here. So you draw a vertical line here. You draw a vertical line. A vertical line using a straight line. Then you call this median. This is the median. That's the median. So that's the median mark. You draw that straight line, you show it at the median mark. So that is part D of the question number 20. So we are done with this question, and that is how you answer it. That is how you answer it. That is how you answer this question. We'll continue with question number 21. We continue with question number 21. Yeah. So that is how you deal with a histogram and questions on statistics 1 dealing with a histogram. So